All right. So the question says consider the series. Okay, we're given the terms in the series. The last term is 9,565,938. So 2.1 says determine a formula for the nth term. Determine an nth formula for the nth term. Now that's a general term as well. Nth term is also called the general term. So first thing, I'm gonna try and determine whether is it arithmetic or it's geometry. That's the first thing. So I'm gonna rewrite the term. So we've got 2, then we have got 18, then 162 plus up to 9,565,938. Okay, let me try to determine if it's arithmetic. 18 minus 2, that's 16. 162 minus 18, that will give you 144, which means it's not arithmetic. If it's not arithmetic, therefore means it's what? Geometry. If it's not geometry, it means it's what? Arithmetic. So you don't have to get confused, because you only did 2 types of series, arithmetic and geometry. So, no. So your common ratio is going to be equal to, say, 18 over 2, that will give me 9. So I said T2 divided by what? By T1. What am I trying to find? The nth term or the general term? So I need the common ratio. I also need the first term. Okay? So my first term is the what? The 2. The first term is the 2. You don't have to get confused. Then the general term is Tn equal to A times R to the power of n minus 1. Okay? That's the general term. Right? Now, here I need a general term, so I just need to substitute. My A is 2, my common ratio is 9, that will be n minus 1. Okay? Please, never ever make the mistake of multiplying the value of A and the value of R. That's incorrect mathematics. Okay? Never do that. So you leave your answer like this. Okay, so I found the nth term or the general term of the geometric sequence. Please take note of that. I found the general term of the geometric sequence from the geometric series. Yes. Alright, then 2.2. Now 2.2 says determine the number of terms in the series. Determine the number of terms in the series. Now, to determine the number of terms in the series, since we don't have a sum for the series, we just have to use this general term to determine n, the number of terms. Fortunately, we know the nth term or the last term is 9,565,938. So where there is Tn there, I'm going to put that. Okay? So let's do that. So I'm going to move on to the next page. So the next page, I'm going to say 2.1 is 9,000. So it's 9,565,938. This is going to be equal to, it's equal to 2 times 9 to the power of n minus 1. Right? Now, before you go anywhere, you have to divide both sides by 2 first. If you do that, you get 4 million and what? 4,782,969. Like that. That's equal to 9 to the power of n minus 1. Then, I told you how to use a calculator to convert any number to a what? To a prime base. But in this case, if the calculator converts the 4,782,969 to a base of 3, it means you have to convert that 9 to a base of what? 3. So 3 to the power of what? 14. which means that I have to convert it to 3 to the power of 2n minus 2. Okay? You don't have to get confused. Your heartbeat does not have to increase because you saw that question. Then from here it becomes a grade 10 and 11 question. Okay, remember your number of terms must always be positive. So you get 16 equal to 2n, so your n will be 8. And then you are done. Okay. Any question? Right, another way, can I have your attention, is to convert this 4 million to a base of 9. You can convert to a base of 9. It will be 9 to the power of 7. Then you simplify, you still come up with something. Okay. That's it. So if you make some mistakes, just do your corrections. Okay? Let's move on to the next one. Then 2.3 says express the series in sigma notation. Express the series in sigma notation. Now, to express the series in sigma notation, remember, we have to write it this way. I'm just going to write the answer anyway. Right? So, for 2.3, we say sigma. We are starting from n equal to what? To 1. How many terms are there? Up to n equal to what? To 8. Okay? There are 8 terms in the series. 8 terms. So we start from n equal to 1 up to n equal to what? To 8. Now, we have got 2 times 9 to the power of n minus 1. That's the general term. So now I'm going to show what about it to work out in the rest of the okay. What about you decide to come to a lesson, you didn't want to go to the toilet, then you must go for it.
Sir? Alright, we said before, we can't come to the class late since you come here and then also go to toilets.
No, listen. You go to the toilet in the other lesson, before the other lesson.
It's freaking great.
You're supposed to go to the break time.
Yes, this is 4th period.
Yeah, but the previous lesson you go to the toilet. Period 1 and 2 you go to the toilet.
No.
So why have the maths there?
That's really bad.
Alright. Okay. Just make it time and make sure that when you come, don't toilet.
Okay, sir.
Alright. See. Alright. So if you substitute n equal to 1 here, 1 minus 1 gives you 0. 9 to the power of 0 gives you 1. So mean the first term is the 2. Please take note, this is the general term. If your general term is incorrect, it means when you write your sigma notation, you get an incorrect answer. So you make sure you know how to find the nth terms or general terms of an arithmetic sequence and a geometric sequence. So this is the answer. Okay? Then 2.4. It says calculate the sum of terms in the series. Right? Now we need the sum of what type of a series? Geometry. Okay? So to calculate the sum, first, right? Our first term is 2. The common ratio is what? The common ratio is a 9. Okay? The number of terms is 8. Okay, because I found it in 2.2. So I'll write my formula. Let me use a different color. So it will be Sn equal to A times R to the power of n minus 1 over R minus 1. Now we want the sum of 8 terms. So where there is n here, you put 8. The first term is a 2. The common ratio is a 9. The number of terms is 8. If you simplify that, what do you get? Use your calculator quickly. So that's 10,761,000.
10 million. It's outside the price. I can't think it.
Okay. Are you all getting that number?
Yes. I'm gonna say.
Okay. I hope you are aware that this was homework. You are supposed to have the answer. What answer did you get?
No, sir, no, I don't know that. I said some honest, yeah.
What's the number of terms?
Said
8. The number of terms is 8. If you say 8 minus 1 plus 1, it gives you 8.
yes.
Yeah.
That's how you calculate the number of terms.
Okay?
Yeah.
In my case, I don't need that formula because I know that if you are starting from n equal to 1 up to n equal to 8, there are 8 numbers. Okay? So we use that formula to just make things easier in order to avoid mistakes, to calculate the number of terms for the sigma notation. But what is minus 1 plus 1? Okay. All right. So you can use this. If you think you can get proceed to the sigma notation, you can use that. All right. Any question? I wonder what answer you got here. I'm talking about when you did it on your own. What answer you got? If it was different, then how did you get your answer then? If you got a different answer from this one when you did it alone, why did you get a different answer from me? How did you do it?
So I used the wrong thing.
You used your general term was incorrect.
Yeah. No, it was my general term was great, but I used the wrong method.
Yeah.
I used A plus AR plus AR squared plus AR.
Okay.
My guy.
Okay. Don't complicate things. If the question is saying calculate the sum of the series, use the formula of the series that I derived in class. The SN formula. Those are the ones that you're supposed to use. Don't try to do it manually because some of the series can have lots of digits. If you try to do it manually, you can end up having major problems. Just use the what? The formula. Find your first, if it's geometric, find your first term, your common ratio, your number of terms. And then you use this formula, the substitute, to simplify. That's it. Don't complicate it. If it's arithmetic, find the first term and your common difference and your number of terms. And then use the formula. Then you'll be done. Okay? Right, let's move on to the next one. Right? So that one now says find n. Now n is the number of terms. Okay? So to do this question, and I have your attention, what this means is the sum of the series is 255. So Sn is 255. So I've got the sum. But I need to determine what is the first term, what is the D, or what is the R. But from my experience, because the K is an exponent, it's geometric. Okay? You hear what I'm saying? Because we have got K as an exponent, means it's what? Geometry. So what I'm going to do is I'm going to expand the sigma notation. So sigma from K equal to 1 up to N is equal to. I'm just going to expand it so that I can determine the first term and common difference. So if I put k equal to 1 there, I'll get 2 to the power of 1 minus 1, which will give me 2 to the power of 0, which is what? 1. Are you following?
Yes.
Then if I put k equal to 2, 2 minus 1 gives me what?
2.
2 minus 1 gives me what?
1.
1. Then 2 to the power of 1, you get 2. Alright. Okay, plus, if I put k equal to 3, 3 minus 1 gives me a 2. So I'll end up getting a 4. Then you say plus plus. Right? Why am I doing this? I want to determine the common ratio. So my R is going to be equal to 2 over 1, which is what? Which is 2. So the first term is going to be 1. Okay? Remember, I need to find what? N. And the series is geometric. Okay? So, which formula should I use? I must use Sn equal to A times R to the power of n minus 1 over R minus 1. We are using this formula because the series is geometry. Or you can say the series is exponential if you want. Because a geometric sequence is also called an exponential sequence. Okay? Be very careful. Make sure you know the difference. Because some learners may use the formula for an arithmetic series. I've seen it happening in the past. So know your formula. Then from here now, when I substitute, where you have got Sn here, you put what? 255. 255 is the sum of all the terms of this geometric series. So I'll put here, let me use a different color. So I'll put 255 is equal to, my first term is 1, and then my common ratio is a 2. That will be 2 to the power of n minus 1 over 2 minus 1. Okay, so this will give me 255 equal to, the denominator becomes a 1. 1 times 2n will give me 2 to the power of n minus 1. Then I'll end up having 256 equal to 2 to the power of n. Can you convert 256 to a base?
Negative 2 to the power of 8.
No.
It's negative 2.
No.
So you don't want to say there's something wrong. 2 to the power of 3. 2 to the power of 8. It's negative 2 to the power of 8.
Keep your foot. Don't complicate things. Is this 255 positive or negative?
It's positive.
Yeah, wait. Can you calm down? Can you calm down? If you use the second, the other formula, then you must say so. Remember, there are two formulas.
Yes, exactly.
I'm doing it based on I'm doing it based on the formula that I was. If you use the other formula, you end up getting negative answers.
It's not negative.
I'm talking about the 256 will be negative.
Yes. Even the other side
Alright, can I get on please? Can I get on? When I introduced the geometric series, I told that I prefer the first formula. I told you that.
Yes.
Right? If you like the second one, like here, it's fine. But for now, since I'm the one who's writing things on the board, let's do it based on my formula on the board. Yes, to avoid confusion, because we have got two formulas. And I can't do the same question using both of them at the same time. You can use it here. It's your choice. Okay, it's your choice. So based on what I have here, there are no negative bases. So I've got 255 is positive. 2 minus 1 is what? 1. 1 times 2 to the power of n is 2 to the power of n. 1 times minus 1 is minus 1. Take the minus 1 on the right to the left to get to what? 56. And the 256 is positive. Okay? Then you convert the 256 to a base of 2. What do you get? 2 to the power of 8. Right? Then n is going to be equal to what? 8. That's the answer you got.
Yes.
I wonder why you like the second formula.
Chill.
I wonder why you like the second formula. Because the second formula, it will produce some negative values.
Yes.
Which, if you're not careful, sometimes you can make unnecessary silly mistakes. Anyway, so I've got the number of what? Of terms. Any question? Any question? Because, do you have a question?
I'm fine.
Are you following what I'm doing?
I'm fine.
Okay, Anele? Okay. Alright. So from here now, if you don't have any question, okay, Jana, are you okay? Okay, let me introduce the last part of your grade 12 sequences series, which is the concept of sum to infinity. Okay, sum to infinity. Okay, up to this point, can I have your attention? Can I have your attention? I won't be able to do every question in the textbook, it's not possible. Alright? Yeah. But I'm very confident that up to this point, I've covered all the key things that you need to answer questions on sequence and series, excluding sum to infinity. I've covered all the key things that you need. So if you take a past examination paper, don't answer questions on sum to infinity as yet, you should be able to answer all the other questions. Well, the tools are there. Okay, so let me move on to the last part. Sum to infinity of a convergent, okay, infinite geometric series. Okay? Sum to infinity of a convergent geometric series.